Okay, now let's take a look at a real example. Okay, if let's say for a single measurement, let's say you perform only one time your measurement, so you report the value of your measurement. Let's say the length point A to point B. So let's say the length is x. You measure it x. So length of x is x plus minus the square root of x. So in the single measurement, the square root of the value that you get in your measurement is the can be regarded as the standard deviation. Standard deviation. Okay. So why this is so? It is the reason to say the reason. It will be long argument, so I will not. In, I will not intend. My intention is not to explain it. Mm, next, next, uh, if you measure many times, okay, if you measure many time of the length, let's say you measure it n times, and each time you get x1, x2, x3, so on and so on until x n. Okay, then you find the average, you find the variance, and then you find the standard deviation. mm, uh, you can report your mm, you can report your value, okay, L as average of x plus minus the standard deviation. Okay. Another way to report the result is by using uh, the standard deviation divided with the square root of n. Okay. I cannot explain to you the mathematical reason behind this. It is in textbook, and it will involve long argument. Okay. So if sigma is standard deviation, then the sigma times 1 over square root of n, that is called uh, that is called standard error of the average. Standard error of the average. Okay. So this is standard deviation. This is standard deviation. It also indicate how large is your uncertainty. But this one is it is better, okay, because uncertainty become less when you repeat your measurement many times. Okay, and the standard error of the average, or it is called standard error. Standard error. Okay. Okay. For the earlier example, this one also it is regarded as standard deviation as well as standard error. So in single measurement, what is the standard deviation or what is the standard error? That is the square root of what value you get in your measurement. And when you repeat your measurement up to n times, then you can find, statistically, you can find the standard deviation of your measurement. But the standard error is defined as the standard deviation divided with square root of number of measurement you repeat. Okay, so here the standard error here is the standard error of the mean value. I wrote this. I wrote here standard error of the average. So it is standard error of the mean value in your measurement. Okay. While here is the standard deviation. You can it also can be called as standard error, but that is standard error for a single measurement. Okay. So you are saying to people that when you perform, when in the future, okay, so first you have performed this experiment, and in the future, if you perform it once, okay, you're not repeating n times, but you only do one time, then the standard error in that single measurement is the standard deviation. While here is the standard error for the whole time that involve n times repeated measurements. And I don't know, things are getting complex here. I want to stress you again the propagation, the equation for propagation of error. In the previous video I had, delta z equal to f over round x delta x plus round f over round y delta y, so on and so on. And on the other hand, okay, I have the round f over round x square sigma x square plus round f over round y square sigma y square, so on and so on. Okay. So when you are dealing with calculation, let's say you measure length, okay, length using ruler. Then if you perform the measurement only one time, so then delta x or delta y will be the smallest scale indicated by the ruler. Okay. And that's how to apply the first approach. You can also use the second approach, and many example I've seen that people if the example is with the ruler just now, so people regarded we can regard we can consider the sigma x here, the standard deviation here, as the uncertainty as well. Okay, so sigma x is uncertainty of x, sigma y uncertainty of delta y, even though sigma x square or sigma y square is the variance of or the standard deviation of the variable called x or variable called y. Okay. So so that's it. It is complex, but I think if you know what you are doing, then you will be okay. 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 That's all. Thank you.